I'll start. So my name is Robin. Just hands up, who was in my earlier talk? Okay, welcome back. Glad it wasn't too bad that you decided to ditch this one. For those of you who weren't here, my name's Robin. I work at a company called Confluence. Confluence are one of the companies who contribute to the open source Apache Kafka project. We also have our own distribution called Confluent Platform and our own managed offering called Confluent Cloud, which is kind of cool. I talked earlier about how to get data from databases into Kafka, and we got kind of quite low level. We started talking about transaction logs and funky stuff like that. I showed you some KSQL, which wasn't even on the script, but it was fun to show you. Now I want to talk about something a bit different. I want to talk about how we build pipelines, whether as data engineers, whether as application developers. Whether we're talking about getting data from this database to this analytics platform, whether we're talking about taking data from this sensor over here to process in my application, or from my application to that document store over there, but how we build pipelines and how we should think about doing it in this day and age. Because technology has changed, the way that we reason about data and events has changed, but a lot of us are still thinking about things the same way we have done for quite a long time. And I'd like to suggest we should change that. So when people start off building pipelines, it starts off so simple. We have this beautiful idea of I've got data in this place, and I need to put it in this place. So I'll write a little program to get data from there to there. And it might be PL SQL, it might be Java, it might be a visual tool, but it's data from here to there. And that's fine. And it's beautiful, and it runs, and things are happy, and we've ticked off the requirements. But the thing with data is, it's never just in one place. So our one little pipeline becomes several others. It was kind of successful. Let's take this idea of moving data from this place to this place and add in a few more. And we can start to integrate these different things. And then these things mature over time and they grow up. And we start saying, well, rather than just these different parallel requirements of data from here to here and here to here, we're going to have to start connecting them. And we need to take data from here and use it over there. And then this application needs it there. And then we need it on a message queue over there because this application needs it there. And we need to analyze it over here. And this is what happens. And this is what we've been building for the past many, many years. And most of us have got skeletons in our pipeline cupboard somewhere that we're not entirely proud of. But hey, it worked. But the reason that we approached building systems in this way was that it used to be dead simple. It used to be we just had data in a couple of places, we had a limited set of tools, and how we did it was just how we did it, and that was fine. But nowadays, we have more and more places where we want to get data. It's not simply a case of, here's my transactional system, there is my analytical system, it's either here or there. I'm an application developer, I'll be writing against OLTP stuff in my database over here, I'm building a data warehouse, I'll be in the analytics thing over there. We now have a plethora of different technologies and cloud services available to us, which is generally a good thing. It means that we can use the most appropriate tool for the job that we're trying to do. We don't have to compromise on one fairly mediocre, maybe slightly crappy solution that does most things a little bit well. We can actually say, I'm doing relational graph work, I'm going to go and use this property graph database over here. I need a document store, I'm going to build a search index, I'm going to use this dedicated thing over here. But we have more places that need the data. We also have different teams working with the data. We no longer have the BI team, and they do all of the reporting. We have numerous different people across the organization who are data literate. They say, give me the data, and I'll work with it myself. I don't need a mainframe from the 1970s to go and crunch it and give me a report next week. Give me the damn file, and I'll do it in whatever cloud service I can find, because people are more capable with technology nowadays. So we have more places that the same data is needed. We also have data coming from different places. So I've been talking about the wrong slide, so I'll switch back. But the data that we're working with is coming from numerous different applications. It's not just our one transactional database. It's different services that people are writing. It's no longer just one mainframe where the data is generated. People are writing services in various different languages on various different platforms, and the data is coming from in all around us. It's not just the end-of-day point-of-sale batch file that we get once a night and gets shipped into the mainframe, we crunch away on it, and that's our source of data. We have information about the users' clicks on our websites, their tracking around the store. We have all sorts of different information from all sorts of different places, and we also have to integrate that. And we simply have more data. I mean, big data is somewhat of a trite term nowadays. We've been through the kind of like the Hadoop phase, and people realize, oh, it's kind of, it was interesting for what it does for us, and it still solves particular problems. But the thing about Hadoop that it actually did was it made us more aware that when we're working with larger volumes of data, that the way that we used to do things doesn't always work. We've got more data, different types of data. We actually need to think about how we work with data in a different way. And that's kind of the point of this talk as well. But we still work with data in the same way. Whether it's data that's streaming in, whether it's information coming from sensors around us, whether it's mainframe batch files, we still work with it in the same way. We still say, I'm going to collect up this set of data, and I'm going to wait. And then I'll take that batch, and then I'll go process it, and then I'll go and put it in a bucket over there. So we have data that's happening all the time, and all this data is being generated all of the time, and then we wait, and we don't process it. We think this is a good idea, so leave it alone, because maybe it'll mature and do clever things, and then we'll process it in a batch, and then we'll write it somewhere else, and then they can wait, and then they can process it in a batch. And that's how we do things, because that's how we've always done them. But the data that we're working with from a point of view of analytics is the same data that we're working with from a point of view of applications. And this is one of those human things that organizations have evolved into different teams doing different things, and you're an application developer and you use OLTP databases, and you know nothing about what the analytics people are doing. Because the analytics people have got their data warehouses and their funny-looking boxes and their OLAP things that are super slow, but like crunch loads of data, and the twain never shall meet. So you try and talk to one group about the technology from the point of view of another, and it's like, well, that makes no sense. That's a completely different world. But it's the same data. It's the same data that drives our organizations. So the same data that's needed for an application because we want to respond to something happening, it's that same piece of information that we're going to be analyzing at a broader scale for analytics and diving down into for our data science and our reporting and our machine learning. It's the same data at the end of the day. So the data that powers a particular application within a particular team can also power an organization more broadly. So we have to think about how can we work with this data in a more sensible way, rather than just the old way of doing things. The answer to this, or the root of the answer to this, is events. So events are these fantastic things. Events have got this characteristic of being two things. Events notify us when something happens, but they also give us the state. It's a transfer of state and a notification. It's not just a transient message. A message says, yeah, this happened. You want to know more about it? Well, there's the database over there. State tells us about what happens. Notifications tell us that something happened. And so events give us that ability. So we can actually build systems around events. And events are all around us. Events are what drive our businesses. Events are when a customer interacts with your business. They phone up your call center. They place an order. They walk into your shop. They're human-generated events. But machines generate events also. We have all the sensors around us. We have our applications. They're generating events. Those log files that you're writing out for your applications, they are events. And these events tell us a lot of things. And we can use these events as the basis of understanding how to work with data more generally. Let's think of an example. You've got an online shop. It's an online supermarket, and you can buy your daily groceries. And in the basket, there is some bread, and there's some tin spaghetti. I'm going to have tin spaghetti on toast for my tea. Very nice. And that state is the kind of thing that maybe we've got to nowadays when it comes to analytics. You say, well, we're going to dive down and we're going to do individual basket analysis. So I started doing this quite a long time ago at a retailer, and you would report on how many tins of baked beans did we sell per day, per store. And that was considered kind of like, that's pretty useful stuff because you can analyze all sorts of things. And then someone started to talk about basket data, and you can dive down into what was in each individual basket. And that's like, wow, that's amazing. And there was the apocryphal tale about people who go out and they buy nappies and they buy beer and whatever. I don't know if that was true or not, but people got used to this idea that you can learn more about the information the lower down you go. Well, it turns out that's not the lowest level you can go, because that basket of my tea, it turned out that it got put together in a certain way. So I went into the shop, or clicked onto the website. I was like, well, I need some bread because I need toast. I fancy baked beans on toast. So I put some baked beans into my cart. And then for whatever reason, it's like, well, no, not baked beans tonight. I'm going to have tinned spaghetti instead. So you have all of these different events happening. An item was added, an item was removed. There's your notification. What was added? What was removed? There's your state. And that adding items in and removing items out tells us about behavior. And behavior is what is not captured in state alone. You need the events to be able to rebuild that state and capture the behavior. From the events, you can replay them. From the events, you can get the state. But from the state alone, you cannot unpick the behavior that made it up. So what we need is a system that can capture a stream of events. It can capture a stream of events, it can store a stream of events, it can persist it can process it. Databases are also a stream of events. Databases give us this ability to store state, which is what we all use them for, but databases you can take and you can turn them inside out. You can take the state within a database and you can get events from it. So hopefully I'm starting to open your minds to, or if they're not open already, to the idea of events are powerful and they drive what we do. But you might think, oh, that's a shame. I've only got a database. If only I could have some events. Well, you have events already. Because within a database, you have a table, which is your state. But that table came about from a stream of events. So you had an account balance that came from a deposit. You put some more money, the balance changes. You spend some money, the balance changes again. You have a table and you have a stream of events. If you capture that stream of events, you can rebuild that state, but from that stream of events, you have more information. How often do they deposit money? When did they deposit money? When do they spend money? What's the sequence of events between them? That's more information than you have in the state alone. So this great quotation from Pat Helland, the truth is the log. All you actually need is the log. The database is a cache of a subset of the log. If you have the log of events, you can rebuild your state. All you actually need to do is capture your events. So the events are what we're going to work with in an event streaming platform, such as Apache Kafka. So Apache Kafka is built around this idea of the log. It's an immutable, distributed commit log. Every event that happens, it gets committed to the log. And it's immutable. You can't go back and change things, which in itself gives it some fantastically powerful properties. Around the log, you have various different APIs for writing to it, reading from it, integrating with it. So the log has these messages added to the end. And this is kind of like a conceptual idea. Well, it's also physically how it's implemented as well. And the log is broken up into topics. So if you're more at home with databases, then topics are kind of like tables. It's entities. It's how you want to structure your data. So you might have information about clicks on a website, or orders being placed, or customers as well. Because this is the cool thing about streams of events. You can use streams of events and you can rebuild state. So if you capture all of the events about your customers, as in the reference data, we create a customer, they change their email address, they move house, they blah, 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 blah. Those are events about a customer, but you can rebuild those events into state if you want to know about my customer at a particular point in time. What's the customer's current email address? How many times have they moved house? You can answer different questions using those events. Topics are partitions, and partitions are our units of scale. So you partition a topic, you can start processing it in parallel. You have 10 partitions, you can consume from it with 10 concurrent consumers and process it at 10 times. You can scale out that way. And you also have this guarantee of strict ordering within a partition. So you partition your data based on a sensible key, such as the store or the customer, or however you want to organize your data so that it's evenly distributed. And then you're guaranteed that all of the events relating to that, whatever it is you're partitioning by, are strictly in order. So the messages on a topic, they're just key value bytes. So this is where Kafka gives you the fundamentals with which to build powerful things, but it also gets slightly scary because it takes off the guardrails, takes off the kind of the stabilizer wheels. You have to decide, how am I going to serialize my data? You work with a database, you just do insert into. How's it stored? I don't care. It's just like a database. I just did insert into. Kafka says, give me some bytes. I want a key, I want a value. And it's up to you as the user how you're going to serialize it. So you choose an appropriate serialization method. You can use something like Avro, which supports schemas, or protobuf. please don't use CSV. That's a really bad idea. My colleague Gwen Shapiro has got a great talk all about why you should care about your schemas. It's a quotation from her here. She also has this idea, this fantastic idea, that schemas are your contract between services. Schemas are your APIs between your services. So if you start using Kafka, or if you're using Kafka already, please think very, very carefully about how you're serializing your data. Because the thing about Kafka is, even if it starts off on day one as data from this single thing to that single thing that I completely control, and of course I know what this JSON decodes to, or CSV, heaven forbid. On day 2, on day 3, on day 4, people are like, you've got a stream of orders, that's really useful. I would like a service which responds as soon as an order is placed because I'm going to go and do something else. At which point, if you don't have clearly defined and enforced schemas, things start to go horribly wrong because you can't change things without breaking stuff for other people. So schemas give you this fantastic ability to maintain pipelines which are not brittle. The other cool thing, or one of the many cool things about Kafka, is that it has the ability to persist data. If you're thinking of Kafka in the same way as like, oh yeah, I've got like a message queue, I use this message queue already, Kafka's just like another message queue, you need to kind of adjust that view of it in your mind. Because Kafka persists data. Messages in Kafka are not transient. When you read a message from Kafka, it is not deleted. When you read a message from Kafka, your consumer simply has an offset that Kafka keeps track of. So Sally is our consumer, connects to Kafka, give me the messages from the last place that I read from. When she reads those messages, the messages are not deleted. The offset in the log simply changes. Fred comes along and says, well, I've not read for a while, so my offset is previous. Give me the messages since then. And George the same. So the offsets are specific to the consumer. The messages are just persisted in this log. And you can persist the data forever if you want. You can persist the data based on time, based on size. You could say, I have a business requirement to keep the data for 10 years. Keep it for 10 years. I have a business requirement, it's click data, we don't need it kind of like beyond a couple of days. Or I want to keep the last 10 gigabytes worth of data. You can configure it per topic. There's also a very, very cool thing called compacted topics, which is where Kafka keeps the latest value for every single key forever. So even if you haven't made any changes to that particular key for 20 years, you'll still have the latest value for that key, which means you can start to think about using Kafka for storing reference data, configuration data. You simply say, here's my key, and here's the latest value. Or here's a change to that value. And at some point, Kafka will go through it or compact things down. It might age out previous values, but every key, it retains the latest value. That's super, super powerful. So for getting data in and out of Kafka, you have the producer and consumer APIs. There's Java libraries, C, C++, Python, blah, 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 blah. Any programming language you're using, however obscure, almost certainly there'll be a client for it. If there's not, there's a REST API for Kafka. So you can then just send and receive using REST calls. But if you're integrating Kafka with other systems, you have Kafka Connect. So Kafka Connect is part of Apache Kafka, and it lets you stream data in from numerous sources, out to different targets, or indeed from both. Stream data in from a database, stream it up to Snowflake. Stream data in from a message queue, stream it over to S3. And you can also process data in Kafka. So Apache Kafka has built into it a processing API. It's called the Kafka Streams API. It's a Java library that lets you write stream processing applications. And if Java's not your bag, or if you'd rather use a different language, you can use SQL. So KSQL is built on top of Kafka Streams, and that is a stream processing application. There's no boilerplate code that sits around it. You simply deploy that statement, and then that takes an inbound Kafka topic, filters it for the predicate, writes the results back to a different Kafka topic. So all of this is kind of different. The biggest mistake that people make with Kafka is to think, well, I'll just kind of like put it into this existing thing that I know about. It's kind of like a database, or it's kind of like a message queue, or it's kind of like an ingestion bus, and it's not. Kafka is something fundamentally different, and if you try to use it in your architectures in place of an existing thing, it'll either go horribly wrong and you'll say, Kafka's a piece of crap, I shouldn't have used it, because you misused it, or you'll not get the best out of it. If all you're doing with Kafka is using it as kind of like an ingestion pipe from here to over there, that's fine, that's great. but that's massively underusing what it can actually do. So let me give you an example of some of the things that you can actually build out using Kafka. I'm going to show you this example, and then I'm going to show you some patterns around it for particular problems that Kafka helps solve. So if we think about events, events generated from websites, events generated from an application, something's writing events into a Kafka topic. They're using the producer API, they're doing whatever, it's your application. It sends review events. People leave reviews about a certain thing, it goes onto a Kafka topic. Okay, we've got data flowing into Kafka. And what we want to do is we want to put that data in front of our operators. It's an e-commerce website, people are leaving reviews. We want people to keep an eye on those reviews. Are they good reviews? Are they bad reviews? Are they rude reviews? So we want to be able to do that. So we can take that data from Kafka and we can stream it straight over to somewhere like, I don't know, Elasticsearch, Kibana on top, happy days. We have a real-time view of all of the data that's flowing into Kafka from our production application. But we can use the same data and say, well, that's our operational dashboard. They're watching the stuff that's happening at the moment. But our data science team would also like to have access to those reviews because who wouldn't? That's valuable information. And here's where we start to touch on the whole point of using Kafka, because it's the same data. We don't have to go back to our source application and say, well, you're writing it to here, can you also go and write it to there? Or we want to get the data for our data science team and tell them, well, go and pull it out of Elasticsearch, which is kind of a crappy way to do it. We can say, well, we'll take that same data and we'll stream it from Kafka down to our data lake. Now our data science team can go and do their cool stuff against it from the data lake. But you can do more. You can use Kafka to process that data. You can say, the data that's coming in, there's a bit of a glitch in the producer. Sometimes we get null ID columns. So if it's got a null ID, it's useless because we can't associate it with a user. We want to ignore that data. We need to cleanse the data. But now we've got two places in which we're using it. We've got our operational dashboard, we've got our data lake. So how are we going to clean that data? We could write a process in the data lake, which runs periodically and picks up a batch of data and then processes it and writes it back. We could have something in our operational dashboard. We kind of hard code in a filter or do something like that. But now we're maintaining logic in two separate places. We can actually process the data as it flows in. We can say the data's arriving in this topic. We've got an application that's running that subscribes to that topic, filters out these bad records, and writes it back to a new topic. So we've now got a new topic called something like reviews clean, and that's the one that we then stream down to the different targets. We need to change the application logic around it. We change it in one place rather than multiple different ones. And if someone says, actually, I want to know all of them, warts and all, they can still subscribe to that original topic. Maybe we want to enrich the data. We've got information, these reviews are coming in, but all we have in terms of who left that review is the user ID. User ID 42 loves baked beans. Who's user ID 42? Maybe we can send them some promotional tokens. Well, we can get that information from elsewhere. We hold information about our users, probably in a database somewhere. You can take data from a database and stream it into Kafka. You've got the transaction log. If you're in my earlier talk, you'll know all about this. Databases are a source of events, just as anywhere else. Stream that data into Kafka, and then use Kafka to enrich that data. So you do a join from the events that are coming in, join it to the information about the users, write it back into a new Kafka topic, and stream that down to our dashboard, down to our data lake. So you can do these iterative improvements to the data along the way. Applications can choose to use it or not use it. They might subscribe to a different version of it, but you're writing it back into Kafka for everyone to use. And all of this is event-driven. All of this is low latency. As things are happening on our website, as data is being produced into Kafka, we're enriching it as events arrive, we're writing it back into Kafka. So far, I've talked about using the data kind of from an analytical point of view. So taking the data into a dashboard, data into a data lake, kind of analytics, kind of like application developers starting to switch off. This is kind of boring. Dashboards, boring. But actually, it's a stream of data. So we can write applications against the stream of data. We can say, well, actually, I'd like to know and write a notification service, which is going to tell me if one of my users, who's like platinum user, they spent a ton of money with us, if they leave a bad review. And we could say to the data science team, well, can you go and like mine the data lake and tell us last month which users were kind of like unhappy? And then we can kind of like try and rectify it and send them a token and say, well, we're sorry about that, please don't leave. Well, it turns out they're doing that once a month, the user's long gone. They had a bad experience, they went somewhere else. That's what users do. It's like, do I use this app, that was crap, I'll use this one. Simple, it's kind of like brutal, but that's how we do it. Well, what about if we can do it in real time? What about if we can say, as a user leaves a bad review, cleanse the data, join it to the user, now set a predicate and say, if they're a super important user and the review star rating is below a certain threshold, write it out to a new topic. Well, there we go. There's our stream processing application. Create a new stream of unhappy users where the rating's less than 3 and they're a platinum user. Now we've got a Kafka topic with just that data in, with the user details, email address, and so on, that our service can subscribe to. And all we need to do as application developers is say, subscribe to this topic. If you get a message, go and email that user, phone that user, do something to try and make things better. But that's within seconds or milliseconds of it actually having happened. They leave a bad review, now we know about it, we can do something. But we're using the same data. It's the same review data that we need for doing applications and analytics. I want to talk now about some of the patterns that are useful in considering something like Kafka. Because it's not always going to be the all singing, all dancing thing. It's usually when you pick a particular couple of things which will be like, we should probably look at using this. Or maybe we shouldn't. Maybe it's completely inapplicable for our use case. But there are usually like 2 or 3 particular drivers that make people think this is going to make a lot of sense for us. One of them is simply that not everything is a nail. You don't always just want to be hitting things with a particular hammer of like your generic technology solution that you've chosen. We're going to use like a relational database because it doesn't suck at everything. That's a fairly low bar to set that it doesn't suck. How about we're going to use the best tool for the job that we're trying to do? We're going to use a relational database for doing relational database things and kind of like storing super important data and transactional things and globally identifiers and the kind of stuff you'd use a database for. But then we need to build a search index. We're going to use a search tool for that. And then we're going to do graph analysis. We're going to use a graph tool for that. But we've got the same data flowing into Kafka, and we can use it in multiple different places. If our database goes offline, the other 2 things aren't impacted. We can still send data to those. If we want to upgrade one of those pieces, we're not impacting those other things. We're not starting to build out these horrible spaghetti architectures. So one of the things that Kafka gives you, and hopefully one of the main things you'll take from this, Kafka gives you the flexibility to evolve. You don't have to commit on day 1, this is the stack we're going to use, like it or lump it for the next 5 years, until we get a chance to kind of reevaluate and kind of realize how much we did it wrong last time. Or maybe we didn't, maybe we got it right, but we struck lucky. But a lot of the time, technology is changing so fast that you want that ability to be flexible. You've got your data, where do we want to put it, when do we put it there? You can also use Kafka to try out different technologies side by side. We decided we're going to do some analysis. We need some kind of like data lake, data warehouse type platform. Do we use HDFS on premises? Do we use BigQuery? Do we use Snowflake? Who knows? But let's try them all side by side. We've got the same data coming in. We're not having to say to the source application, can you send it to these 3 different places? We're not having to say, well, we'll probably use HDFS and then we'll do like a bulk extract from there and stick it up to there, but we're not sure if it's the same copy of the data. And we've now got a new feed, and can you do a new copy to update those ones? That's kind of like the path of madness. And we do it sometimes because it's important to try out technologies side by side to do it for a fair evaluation, but it's a massive pain. How about if you could take the same stream of data and send it to all 3? And then when you've picked on the one that you like, we'll just turn off the other 2. You've built your pipeline already. It's not a case of, right, this is great, now let's take it to production. You're done already. You can also evolve the other end of the pipeline. You can say, I've got my producer, I've got my application, it's running on premises. It's got a couple of different consumers that need that data. But now we're going to move to the cloud. We've been to the conferences, we've heard the benefits of cloud. We're going to do kind of like drink the Kool-Aid. We're going to move to cloud. So now we've got a producer that sits running up in the cloud. We don't have to re-hook our consumers up to 2 different places, or have our producer know about the 2 different places that it's sending to. And if all works out, we say, well, this is great. We're all in on the cloud. We can turn off the on-premises bit. But you'll see in all of this, we're decreasing the amount of coupling that we've got going on between the pieces. Because the coupling, tight coupling of things makes it less flexible. It's easy to understand how these things happen. On day 1, someone says, your requirements as a developer to meet your requirements, your KPIs this year, is to build a system that takes data from here and puts it in a database. Fine, I'll do that. Data, database, done. And then someone says, well, turns out we need that same data in a data lake. Okay. So we put it in the data lake, and we'll do like a scoop job to take it out of the database, and we'll put it in our data lake, and that's fine. But then someone says, okay, now we've got an application that needs that same data, but this application, we're going to consume it from Kafka. So can you write a job that's going to take it from our data lake, from HDFS, and put it into Kafka so it can consume it from Kafka? At which point you're like, no, that's a bad way to do things. And so you start trying to rewire different pieces along the way, and it just doesn't make any sense. It's completely understandable, each particular decision. Let's evolve this, let's add on this, let's bolt on that. That didn't scale, so we'll add this bit on. But you soon end up in a right old mess. So with a bit of foresight, on day one, you say, well, okay, let's give this Kafka thing a try. We'll say, we'll take our data, we'll stream it into Kafka. From Kafka, we can stream it to a database. So we've ticked off our requirements. We've got Kafka there, because it's going to come in useful when someone says, well, we want that same data in our data lake. At which point you say, yeah, this is cool. I feel smug. Because I simply say, Kafka connect, that topic, that data lake, done. And you say, well, turns out we actually need to upgrade that database. In the previous version of things, we'd say, well, that's going to screw our data lake until you've finished upgrading your database, because that's like slap bang in the middle of things. In the new version of things, you say, I feel super smug now, because you can turn off that database, I don't care. Because I have the data in Kafka streaming down to my data lake, and the new application comes along, says, oh, this is great. I already have that stream of events that I need. There's very little data that's not useful in multiple places. Maybe today, it's like, well, here's your requirement to build this to go from here to here. But tomorrow, next week, 6 months, a year, there's always going to be other people who want that data. You can use Kafka for cleansing the data, like I mentioned. You've got the data streaming in. You want to use it in multiple different places. So we've got IoT devices, we've got thousands of IoT devices. They're streaming their data into Kafka, and you've got different applications using it. You've got a database in there for good measure. Lots of different people using the same data. Great. Turns out, devices are a bit faulty. They send bum readings. So sometimes you don't even get a sensor ID. So do we put the cleansing logic in each and every consumer, and we need to know exactly what's the kind of fault and how do we code around it? Or do we say, well, that's fine, we can transform it once, we can filter out those bad records, we can write them back into Kafka, and now each consumer, wherever they are, they can just subscribe to a clean feed of data. They don't have to know about warts and all like what went on up there. And the same idea, we need to enrich the data. This is the traditional way of doing things. I have something happening, I subscribe to that thing, and now I, as an application, I'm going to take responsibility for doing lookups out to a database. I need to find out about these products, and what's the SKU, and what's the color, and what's the cost code. I'm going to do a lookup to the database. And things start getting a bit slow because we keep polling the database. So it's like, well, I suppose I could take that database and bring it into like a cache within my service that I've written. Now I need to worry about how do I keep that cache consistent and like invalidating it, and this is like a lot more complicated than it needs to be. Turns out other people also need to do that same enrichment. Your application needs to enrich it, analytics needs to enrich it. Everyone needs to know what the SKU was and what the color and the cost code. So you bring that data into Kafka, you enrich it once, and everyone has access to that enriched data. You can also use it for unifying different systems. So you've got the same type of data coming in. We've got squares coming in, and a new version of the software comes along, or a new third party comes along. They send us the same logical data, but they say, we're going to use triangles. Squares are kind of like, they're a bit old-fashioned. I prefer triangles. They've got a nicer kind of feel to them. I was like, well, that sucks, because I want to be able to use that same data from these two different people, but I need to be able to understand it being the same thing. So we write a little stream processing application. It reads from the source data coming in, transforms it, writes it back into Kafka onto the same topic, and our consuming application, it just gets the new data. Squares and triangles, obviously a bit abstract, but there are numerous times where we have different systems producing the same logical data, but in different formats. You can unify your data within Kafka, and then your different consumers have access to that data without needing to implement the logic themselves. We can also use Kafka to apply schemas to data. So heaven help us, you've decided to use CSV. That's a horrible idea. Someone said it was a good idea. It's not. It's a horrible idea. But we're sending CSV data in. Our producer, they didn't get the memo. They're sending CSV data into a topic. We've got two different applications reading from that topic. They want to know about the sales. Each of those need to know, how do I decode that CSV? What the hell does this column mean? Is this comma part of the format? Is it part of the column? I don't know. Heaven help us, we're using CSV. So a much better approach is, other than like slapping the producer around and saying, don't be daft, is we could say, well, we'll write a stream processing application, we'll use KSQL, we'll use Kafka Streams, we'll use whatever. We'll apply that schema to the data once, and then we'll write the data back into Kafka in a much more sensible format, such as Avro. And then our consumers can read that data with a schema available to them. They don't have to implement that logic themselves. So I would strongly urge you, try to think forward from what you're building here and now. Try to think about 1, 2, 10 iterations from where you're at. Don't set the foundations for something which is brittle and going to need to be rewritten. Set the foundations for something which can evolve flexibly. If you don't need to evolve, then brilliant. It's still working. It's still got something which gives you back pressure and scalability. But almost always, it's going to need to evolve. You'll want to use a different technology. You'll want to upgrade the version of something you're using. You want to scale out the version of something you're using. And then you're set for success with it. Don't build yourselves a spaghetti architecture. That's what we've done in the past. That's what we always do. That's what we're kind of trained to do. I need to do this. I'll kind of copy it to there and consume it from here, and then write it over there, and then put a batch over here, and it ends up a right mess. Instead, build around Kafka as your event streaming platform. Do your processing within Kafka. Do your processing locally. I don't care. This is not kind of like recreating the ESB. This is something different. You can enrich your data wherever you want to, but you can share it amongst the producers and consumers of your data. You can integrate with existing applications. You can integrate with databases. You can do stream processing. But at the heart of all of this are events. The events are our lowest granularity of data. Events are what model what happens in the world. As soon as we start storing something beyond events, we start aggregating up, we start losing that detail. We lose the detail, we lose the behavior. So events give us this ability. So the event streaming platform, something like Apache Kafka, it lets us persist the data, it lets us replay the data, it's scalable, we can do stream processing within it. If you want to try it out, you can use Confluent Cloud, manage Kafka, manage schema registry, KSQL, and so on. If you want to learn more about Kafka, go and download the books for free from our website. I'll leave the slide up there. You can scan the QR code. I hope that's been useful. Thank you very much. I think we have 8 minutes for questions. Any questions? Yes, right at the back. You'll have to shout.
How would you answer that you moved your dependencies just from Kafka? So instead you said that we are coupling, and instead of coupling, Kafka offers flexibility.
Yeah.
How would you answer that you just shifted the flexibility or the dependencies just to Kafka?
Okay, so the question is a very good one. The question is, how would you address the question that all you've done is redrawn that picture around a different dependency. And now instead of being tightly coupled around something else, you're tightly coupled around Kafka. Is that a fair paraphrase? Okay. So I would answer that in that Kafka gives you the foundations. It gives you this concept of an immutable commit log, so you're guaranteed ordering. It gives you the scalability, and it's agnostic to the data format. So how you get that data in, what you do with that data, where you use it, is up to you. Because everything integrates with Kafka, and gives you that ability to scale it out, and it's highly resilient. You can scale it out for redundancy and so on. So yes, it's a point of failure, but it's highly resilient and distributed, so you can make sure it doesn't fail, or you can get us to run it and it won't fail. So yes, I'm not going to say, oh no, it's not a single point of failure. Yes, it is, but it's a highly resilient one, and it's also very, very agnostic to your formats of data. If you go all in on a database, or you go all in on a message queue or something, you're dependent on how that data is stored, and also the peculiarities of how it decides to model that data and state. Whereas Kafka is built around events. And events are your base unit of data. So if you want to go and do an event-driven application, you can. If you want to go and rebuild state, you can. Whereas if you say, well, I'm just going to use a database. Screw Kafka, I'll use a database. Now you just have state. And you could kind of like cobble stuff together with triggers and blah, 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 but it's not the fundamental basis of a database. So I think Kafka is much better suited to being that platform on which you build other things. How's that sound? Good. OK, awesome. Other questions? Yeah.
So, am I getting you correctly that your opinion would be any type of project I start, Kafka should be in it, basically? Like,
Yep. Every single one. Hello world, Kafka. Yeah. No. So there are some things, if you're building something self-contained, that you're not passing data around or something, then why do you need Kafka? But as soon as you start integrating things, as soon as you start building services that want to exchange data, as soon as you have state that's being passed around, then it's a good idea to look at something like that. It's a good idea if you're reaching for instinctively, oh, I'm going to go and use XYZ message queue, or I'm going to use XYZ database. It's like, is that appropriate, knowing what I know now about events? Or would something like Kafka be suitable? And sometimes the answer is no. Sometimes the answer is, yes, I'll just use a database. But it's that idea of taking one's blinkers off and just kind of like muscle memory of, I'm building an application, I need a database, I need to pass messages, I'll use a message queue, to actually, well, does it let me replay my events? Does it give me access to the behavior as well as the state? Does it? So not always, but a lot of the time. If anything else, challenge how you're doing things. Would Kafka help here? Would it set the foundations? And if not, don't use it. I don't want to kind of ram technology that's not appropriate down people's throats, but I do want people to think about how they build things rather than just, well, we've always done it like that, we'll keep on doing it like that. Anyone else? Awesome. Thank you very much. Oh, go on. Oh, we just beat the cloth.
Just how would you avoid that the single source principle is kind of messed in keeping your KSQL statements in accordance with the source code?
Sorry, you'll have to repeat.
The source code has some Kafka stream description and your KSQL description. How can you match them together?
I'm not sure I understand. Come and have a chat with me afterwards, and we'll chat about it. OK, I'll put the slides online. I'll tweet it. Last question at the back.
Thank you for the great talk. I have only one question because you said it's an immutable log.
Yes.
And we have in Europe a data privacy.
GDPR, yes.
Customer comes to me and says, hey,
Yeah.
please delete my data.
Yeah.
Is it possible to do it?
You can do it in effect. So if you're using a compacted topic, which is that thing I told you about with it keeps every value forever, and it's like, oh, GDPR is going to get pissed, you can actually put what's called a tombstone message, which is a null value. So you say, for this key, null value, and then the log gets compacted, gone. You can also, the other common pattern is using encryption keys, which you throw away. So you encrypt your data on the Kafka topic, customer says, delete my stuff. It's like, hey, I will prove that I've deleted the key. Now that data is, to intents and purposes, gone. So that's two common patterns around it. There was a talk at Kafka Summit, I think it was San Francisco, it may have been New York this year, by David Jacko, and he talks about a very cool solution that's built around the concept of it that goes into much more detail. So go and look that up as well. OK, thanks very much.